We're going to use a definition of the derivative to differentiate f of x equals 1 divided by x squared plus 5. Recall the definition of the derivative. It's defined, f prime of x is defined by the limit as h approaches 0, f of x plus h minus f of x divided by h. So we're going to do this in steps. The first step is to compute f of x plus h and simplify it as much as possible. This is 1 divided by, instead of x squared, instead of x, we put x plus h in parentheses, then square it, add 5. Now the only thing we can do to simplify it is to expand x plus h squared, which is x squared plus 2xh plus h squared, and then 5. So this is f of x plus h in its simplified form. The second step, we take f of x plus h, what we just did in step 1, subtract f of x. Again, simplify as much as possible. The idea is to, at the end of step 2, we should have h factored out. This is 1 divided by x squared plus 2xh plus h squared plus 5. Subtracted from that is f of x, which is 1 divided by x squared plus 5. Now we're going to combine these using a common denominator, which will be the product of the two denominators. And to do that correctly algebraically, this one here will be multiplied by x squared plus 5, and then this one here will be multiplied by the other denominator, x squared plus 2xh plus h squared plus 5. And this is what we get after that. We get x squared plus 5 minus, you want to make sure you keep everything in parentheses, x squared plus 2xh plus h squared plus 5, and then the denominator is the product, x squared plus 2xh plus h squared plus 5 times x squared plus 5. Now do not expand, do not multiply the denominator. You don't have to do that. We'll deal with it at the very end. Concentrate on the numerator. Notice in the numerator we have x squared minus x squared, and then 5 minus 5 also cancel, and what we have left in the numerator are terms that contain h, and that's always the case in problems like this if you did it correctly. Don't forget the minus, so we have minus 2xh minus h squared, and all of this divided by the product x squared plus 2xh plus h squared plus 5 and x squared plus 5. Now we want to factor in h from the numerator. That's the goal. At the end of step 2, we always want to factor in h. Of course, that happens right here. If I factor h, that leaves minus 2x minus h. All of that, again, divided by x squared plus 2xh plus h squared plus 5 and x squared plus 5. That's the end of step number 2. Step 3, we take what we just did in step 2, f of x plus h minus f of x, and divided by h. So this is equal to h times minus 2x minus h divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5, and all of that divided by h. Now recall from basic algebra, whenever we have a quotient of the form a divided by b divided by c, that's a divided by b divided by c like this. That's the same as a over b times 1 over c, which is a divided by b times c. So when we have similar expression here, it's the same as having this h slide right here in the same level as the product of the polynomials x squared plus 2xh plus h squared plus 5 and x squared plus 5. So let's rewrite that. And this is h times minus 2x minus h divided by h times x squared plus 2xh plus h squared plus 5 times x squared plus 5. And here's the goal of the end of step 3. We want h's canceled, and that's exactly what happens here. The h's have been canceled, and now we can summarize step number 3. At the end of step 3, f of x plus h minus f of x divided by h can now be expressed as minus 2x minus h divided by x squared plus 2xh plus h squared plus 5 and x squared plus 5. We are now ready to compute the derivative. That would be step number 4, the final step in this process. Step number 4, we compute f prime of x by taking the limit of the end of step 3. The limit as h goes to 0, f of x plus h minus f of x divided by h. Let's rewrite that. That would be the limit as h goes to 0. So this is the limit as h goes to 0 minus 2x minus h divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5. Now as h goes to 0, remember h is going to 0, not x. This h here is going to 0. 2xh is also going to 0, and h squared is also going to 0. So what stays is minus 2x in the numerator. In the denominator we have the x squared plus 2xh plus h squared plus 5 term with 2xh going to 0, h squared going to 0. We have x squared plus 5 left, and of course that's multiplied by another x squared plus 5. And we can simplify this to get the final answer as minus 2x divided by x squared plus 5 squared. And so to summarize, we started with a function f of x equals to 1 divided by x squared plus 5, and using the definition of the derivative, we found that the derivative of this function is minus 2x divided by x squared plus 5 squared. For